Hello guys and welcome back to 737 DIY Sim. In this episode we're going to do something a little bit different, and that's try and get your sim operational. It's been a while since it's been powered up and there was a few quirks last time we did it which I need to get fixed. I've also got Prepar version 5 working in the background on the main screen behind me. In the corner here, in the first officer's rudder pedals, we've got the MIP computer. That's just there temporarily. And if I just scroll up, there we go. All the MIP screens are off, which are correct. It is powering them, and it's also powering the left-hand information screen at the moment, which is displaying ProSim panels to the forward and aft overhead. That means when I come to do the switch check on the upper overhead, we can make sure when I push a switch, ProSim thinks it's getting the same command. Makes it really easy for fault diagnosis. And the first fault we can see is that we've got all our 7-segment displays showing even though the power is off. Here we are on my main computer. I've got ProSim on the left, MobiFlow on the right. Now let me show you two ways that I know of that we can get these displays blanked so when the power is off, nothing displays. If we head over to MobiFlight, and you can see the first line, the output value is greater than -1. Now ProSim has the capability down here on the nav displays to display -1 as off. However, these aren't -1, so what we're going to do is we're going to hit the edit line, and then we're going to select precondition. I am going to ask it for a precondition, and we're going to use the config item, and I'm going to select the list, and I'm just going to put B in for battery master. There it comes straight up. And I want that value to be greater than 1. So 0 would be off and 1 is on. So as soon as the battery master comes on, this display is allowed to come on. Apply that and OK. And as you can see now, we've got the precondition alert icon on the left. I'm going to do that for the other 3. That's that done. Now the -1s are slightly different. What we can normally do with these is we go to comparison. If it equals -1, then we put 8 space bars to blank out the display. And you can see now the output has gone to 0. No longer shows a -1. And we just do that for the same. Hopefully with all those blanked out, we'll head over to the aircraft, and now it should be cold and dark. Well, instantly you can see that the MCP has gone off, and so has the pedestal panels. Now there still is an issue. I'll bring the camera over, and that issue is the decimal points are still showing on some of the radios and not others. So what I think I'll do is I'll just use the precondition tab as well as the -1 to get rid of it completely. So if I stop MobiFlight and then hit run, they should all disappear. That's the MCP, pedestal complete. Now I've put the camera onto the upper overhead. You can see that I've got the elect panel showing -1s everywhere as well, and the LCD display is showing gobbledygook. Let's see if we can get both of those to display nothing. So I'm going to scroll down and find the electric panel. There it is. It's actually highlighted. ProSim has already assigned it a -1 figure. So if we hit the edit line, I'm going to apply the comparison. Again, it's going to be, if it equals -1, I'm going to push the spacebar 1, 2, 3, 4 times. And that should blank it out. As you can see, it disappeared. And let me do that for the same for the rest. Do this as quick as I can so you guys don't get bored. Next on the hit list is the LCD display for the IRS. Now if I zoom you in a second, you can see that it's just displaying gobbledygook, and It's just hit me that I remember why it was doing this now, and it does this every time I load MobiFlight up. There's nothing I can do about it, but I'll show you that on the computer in a second. Let me zoom in so you can see what's happening. So in MobiFlight itself, as you can see, it's started up and it's running. And our navigation displays at IRS are the first 4 lines here. Now if I click on the first line, you can see there's our symbols that it should be displaying. And when we go to the FSUIPC tab, they're not selected. And all I've got to do is tick these every single time I start up, and it should fix the fault. If I stop it and then run, that should now read exactly what it needs to read. Set and it's gone blank. So if I turn on the power, it's fully operational. That's absolutely fantastic. That's another one done. With the sim showing completely off, no display showing, no light showing, what I want to move on to next is the 3D printed starter switches that you may have seen on the website already. They go here at the front, and what I need to do is drop this panel, take the rotary switches out, and we're going to put those rotary switches into the 3D printed parts that I have here. Now the reason we're doing this is because during the start, these should automatically go from ground back to off during the start process. Let's head out to the workshop and get these built. Here you can see the upper body. Here's it without its support casing. And I don't know if you can see it in the inside, but that's where the locking mechanism sits into. But you can just make it out there, I think. This one is with the support structure, and the best way I found to disconnect it for me, so they don't break off that easy, is just to put a Stanley knife blade, watch your fingers, down the centre, and it pops away like that. Next we've got the lower body. Again, it looks a bit like that. And this one is printed upside down, so the support structure is at the bottom. And once again, this should normally just pull off like that, nice and easy. Next up, we've got the actuator rods. Then the actuation cams. Again, they've got support structure printed at the bottom, and hopefully that will just pop straight off like so. And the bases, finally, they hardly need anything doing to them because they're ready to go. They've got no support structure. We are going to need 2 little springs from an assorted spring pack, and they are the compression springs. Next up after that are the 2 3D printed knobs. They're the general bowing ones. And finally we have the solenoids. Now I've got 2 here and I've tested with both. So we've got these solenoids here which are called the XRN 0530. These are the ones I'm using, but I have tested them with these 6 volts running at 12 volts. And they are the JF 0530 Bravo. They work just as well. So taking our upper body, an actuator rod, we need to make sure that there's smooth operation between the 2 units. And I can already feel there's a bit of catching going on straight away. So I've got some 320 grit paper, sandpaper here, and I'm just going to run it down the length of the rod. Make it nice and smooth. I'm just going to try the activation rod into the activation cam and see how it feels. Right, it's going in smoothly, but it is catching on various points. So I'm just going to give the activation rod a bit of a file. Get rid of any raised surfaces. Oh, that's perfect. For the upper body, you can use a bit of sandpaper, or I've got this small round file, which hopefully will do the same thing. Doesn't take much. It's quite soft stuff. That is perfect. Next up is some cheap grease from downtown. This is the only grease they had, so it's the only grease we're going to use. Just going to coat the internal surfaces where the two parts meet. Now, greasing this part up should allow us to use a lower voltage to actuate the unit back. That's the theory anyway. Before we put these two parts together, I'm just going to make sure that there's no burrs and it's nice and smooth on the lower body. Spring on next. We've got our two parts ready to be assembled, but first of all we need to check the fit. We've got a hole in our lower body and we've got a spigot on our upper body. Push the two parts together, compress the spring, align the hole and the spigot here and here, and then just push it in and feel for nice easy operation. And that's feeling quite good. You can see here that I'm using flathead screws, but you can quite easily use dome head as well. Now that those two parts are assembled, just to help with alignment and assembly further on, I'm going to apply the bearing general knob. So the way I put this on is that we have the hole and the spigot going directly to 9 o'clock position, and then we put the general knob in the 12 o'clock position. We push it on. With the upper part assembled, let's move on to the base. So the studs that are sticking out the bottom, they need to go on the outside, and the rotary switch goes in from the outside up, and there's a little locating spigot again with a hole that will help orientate it in the right direction, and we put the nut on. Tighten that into place, and hopefully the activation cam should go directly over the switch. Now they do have a flat side, so make sure the flat side goes on your rotary switch, like so. So in the off position it should be down at that sort of angle. Most of you have seen on the website already that you need to unscrew the cap nut, remove the little rubber O-ring that sits on here, and fit a little spring about 10mm long and put that on. What that spring does is, again, it helps reduce the voltage required to move this round. And I'm aiming on my switches to be operating at 12 volts. I don't want to go and buy another power supply that's running at 18 volts or 24 volts just to get this little solenoid valve to flick the switch back. That's the aim. So if we make it as smooth as possible, hopefully the lower the voltage. What we do is we put the solenoid on, cap nut end towards our actuation cam, like so, and then insert 2 screws. All my screws are 8mm in length, which is why there's 2 studs sticking out of the base, so you don't have to go and buy different sized screws. So hopefully you can see how that looks now. Activation cam is in the off position, and when it goes to the ground, it helps compress that little spring, and we're only talking by a couple of millimeters, but it takes very little pressure to push it back. Now the important part of this is to make sure that the activation cam is 1 notch up into the off position, so it should be around about there, just off the solenoid, again by about 8mm. Our general knob in the upper body is in the 12 o'clock position. Put the 2 parts together and they should align perfectly. They do in here. before you go any further, hold the two parts together and check for operation. Okay, so it feels good at my end. I'm going to put the screws in the base. I'll go and get some power and we'll give it a go. Here's my power supply. Hopefully you guys can see the voltage we're operating at. It is set to 12 volts here. We'll put our switch into the ground position and then we'll just gently touch the contacts together, and it worked no problem. Well, that's great news because that's 12 volts. Let me try it again to make sure it wasn't a fluke. That actually feels quite strong. With our two starter switches now complete, it's time to install them in the overhead and test them out. Now, I thought it was going to be a nice simple job. Remove the old rotary switches, install the starter switches, job done. However, it's not the case. Now, when I designed these on Fusion, they were supposed to stick through the panel, the base being below the panel, and just the rotary switch was supposed to stick out. However, slight miscalculation on my behalf, I made these slightly longer, and now they have to go, the whole unit has to protrude through the back of the light flow panel. And that's what these crazy shapes are here. Also, the ground wires that I used were the cheap 3-strand Chinese wire, and they're broken, so they need replacing because they just keep breaking every time you move them. However, we're nearly there now. And both switches will sit in like that. The back panel's over the top, and job's done. In the meantime, I may have to extend some of these wires, so bear with me while I get the soldering iron out and get this lot wired up. So I've just put a bit of cable sheathing on, and that keeps the cables together and make it look nice and smart when we connect it to the top. When we connect it to the top of the rotary switch right there. So I can work on these ends. Hopefully just going to tie wrap this back a bit. Okay, and the only important one I need to know is that the black goes in the centre pin. And it doesn't matter about the other ones, they can go anywhere. And there's our first loom ready for the rotary switch to go straight in there. That's the unit all wired up. Solenoid valves up here for the starter switches. The relay card is here. We've got the 12 volt power adapter here and the 5 volt rail here. Let's put it up and see if it's going to work or not. So first off, I'm not actually sure which one I've wired up, so I'm going to put them both to ground. Uh-oh. That's not right. So on first test, this did not go to plan. When I actuated the solenoid valves, if I actuated just one solenoid valve, both would actuate. The Arduino itself, Arduino 1N, 1 November, would also restart. It blew the power, it blew the fuse in the 12 volt power rail, and it also restarted my main computer. I thought it may have just been a fluke, so naturally I replaced the fuse in the 12-volt system, and then restarted again. Same thing happened. The fuse didn't blow, but the Arduino blanked out and the computer restarted. It was only when you released the solenoid valve did I have issues. Getting them to operate was fine, but as soon as I let the solenoid valve go, everything started to shut down. And I do believe it was back because I missed the diodes across the contactors of the solenoid valve. Once those diodes are in, and I just used some random ones that I had in an Arduino kit, everything works perfectly. So I can't stress the importance of using the diodes across the solenoid valve to remove the back EMF once you release the solenoid. With everything wired up, everything tested so far, everything's operational. Let's put this panel up and carry out an engine start and see what happens. Now, because I just cut the wires to these rotary switches and put them back in any order, I need to see which wire does which switch. And all I'm going to do is I've got MobiFlight in front of me here, and it's in debug mode. And I'm just going to go into each position, and you can see that N15 is ground, N5 is off, N17 is cont, and N3 is flight. And the same for the other side. With those figures I've got now, I can program MobiFlight to say what pin, N23, N7, goes to which position. I'll configure that quickly and then we'll go for a start. Now that MobiFlight is programmed, I've brought up ProSim panel in front of me here, and that's just to doubly make sure that what I've programmed in MobiFlight is what ProSim thinks is happening in the aircraft. You can see the start switch is hopefully at the very bottom here of the screen. And if I go to ground on 1, it does so on the screen. Back to off, cont, and flight. Same for 2, back to off. That bit's good. So here we are, finally sat in my cockpit. About to do the first engine start, and just like the real aircraft, I need to make sure all the switches are in the off position. What I'm going to simply do is make sure that if they need to be in the off, they're facing towards the tail or the rear bulkhead here. As a general rule of thumb, fuel pumps are off, all the lights are off, APU is off. And let's see if we can go for a speed start. So parking brake on, throttles at the idle, forward right fuel pump on, APU on, and we have to wait for the APU gen bus light to come on. There we go, and now we can put the generators on. I'm going to put the electric hydraulic pumps on, make sure the packs are off, the bleeds are on, isolation valve is in auto, and finally engine fuel pump, start switch to left and hit the ground. Away she goes. %. Open the start valve. My start valve is back to front, I know that. Something to fix later. Good roar of the engines behind us. Currently at 40%. When we get to 50, I'll go up to the start switch. Here we go. Hopefully that will flick off just like that. That's the start switch is fully operational and working now. I'm going to call it an end to this episode, guys. I'm going to sit here now and go through every switch and indicator and make sure it's fully operational. And it does exactly what ProSim thinks it's doing. You may have noticed already that my start levers are back to front. And that's nothing to do with wiring. Well, actually it is. I wired the microswitches in the wrong position. So that means taking the throttle assembly completely apart, which is not something I want to do again. So in the meantime, I'll catch you later, guys. Sim out.